number 5, they say that two particles of masses 0.8 kg and 0.2 kg are connected by a light inextensible string that passes over a fixed smooth pulley. The system is released from rest with both particles 0.5 meters above a horizontal floor. The subsequent motion, the 0.2 kg particle does not reach the pulley. For part A, we need to show that the magnitude of the acceleration of the particles is 6 meters per second squared, and we need to find the tension in the string. So in order to find the tension and the acceleration, first we need to be sure of the direction of the tension as well as the direction of motion. So we are given these two particles, and let's resolve the weight first. So this is 0.8 kg, so that means that it will move downwards. There will be a downward force of 8 kg and this will be 2 kg. So we know that 8 is greater than 2. What that means is that this 0.8 kg particle will move downwards while this 0.2 kg particle will move upwards. Now what will be the direction of the tension? So for this 8 kg particle, the tension will be upwards in this direction, and as for this 0.2 kg particle, it will also move upwards. Now since these two particles are connected by the same string, what that means is that they will have the same acceleration, same distance traveled, as well as the same speed. As long as they are connected and there is tension in the string, these three conditions will hold true. Now in order to find the acceleration and the tension, we can use the forces formula, which is forward force minus resistive force is equal to the mass multiplied by the acceleration. Now we will use this forces formula in terms of both the particles. So for the 0.8 kg particle, the forward force will be its weight which pulls it downwards, which will be 8, and then its resistive force will only be the tension in the string, since the tension in the string is acting in the opposite direction of motion. There is no friction since it is a smooth pulley as mentioned in the question, and then its mass and then its acceleration. As for the 0.2 kg particle, the forward force will be the tension in the string. It helps it move upward, which is the intended direction. So that will be T, the same tension, and then the resistive force will be its weight which pulls it downwards, so it's 2, and then its mass and then the acceleration. So these two are simultaneous equations which we can solve. So this plus t and minus t cancel out. 8 minus 2 will be 6, and 0.2 and 0.8 will be equals to 1a. So that proves that acceleration is equals to 6 meters per second square. And then for the tension, we can just substitute this value of a back into any of these two equations. We'll use the second one. So t minus 2, 0.2 times 6. So that means t minus 2 is equals to 1.2, making the tension equals to 3.2 newtons. So with that, we are done with both the tension in the string as well as the acceleration. So for part B, they are now giving us the other part of the journey, which is when the 0.8 kg particle hits the floor. So what that is telling us is that both the 0.8 kg particle and the 0.2 kg particle have now traveled a distance of 0.5 meters. Since they both are connected by the same string, so they'll both travel the same distance. Now we need to find out the greatest height of the 0.2 kg particle above the floor. This is the pulley and this is the floor. So now the 0.8 kg particle is over here and this 0.2 kg particle is now over here. So once this 0.8 kg particle hits the floor, there will be no tension in the string. What that does is that it changes the acceleration and it will not remain the same as it was in the previous part, in part A. Now we need to find out how much this particle travels upwards without there being tension in the string. In order to do that, we need the initial velocity, the final velocity, as well as the acceleration. when the particle reaches the maximum height, what that means is that it stops moving, and that means that the final velocity will be equal to 0. So this needs to be 0. And the other part of the question is the acceleration. So there is no tension, so we can use the forces formula in order to find the acceleration. So the forward force, there is not any, so the resistive force will be the weight of the particle which is pulling it downward, so 2, and then the mass is 0.2 and the acceleration is unknown. Dividing 0.2 on both sides, we get -10, which you will also note is the force of gravity. So the particle is moving against the force of gravity, so it will now have an acceleration of -10. Now we have the final velocity, which is 0, then the acceleration. What we don't have is initial velocity. As we established in the previous part, we said that as long as both the particles were connected by the string, they will have the same speed, acceleration, and the distance. So the initial velocity of this particle will be the same speed of the other particle when it hits the floor. So now let's look at the initial velocity and how we can find that. Now we will look at the part of the journey before collision. So they said that the entire system was released from rest, making the initial velocity equal to 0, and we found out the acceleration in part A, which was 6. This was when they were connected by a string. The final velocity is unknown, and since the particle hits the floor, we know that the distance is equal to 0.5. So now we can find the initial velocity, or in this case the final velocity, using the v square minus u square is equals to 2ax formula. So the final speed is unknown, and since initial is 0, we won't write that, times 6 times 0.5. So the final speed, this v squared is equals to 6, making the initial or the final velocity is equals to under root 6. So now we have this final velocity, which will become the initial velocity in this part. So the distance the particle travels is unknown. The acceleration we figured out is -10, and the initial velocity is now under root 6, and the final velocity is 0. So 0 squared minus 6 is equals to 2 times -10 times x. So -6 is equals to -20x, and dividing 20 on both sides, we get that 0.3 is equals to x. This is the distance the particle travels after the 0.8 kg particle hits the floor. Let's map the entire journey. So they're asking us for the height above the ground and not the distance that the particle travels. So initially both the particles are 0.5 meters above the ground. So this will be 0.5, and then the particle travels 0.5 meters so that the other particle hits the ground. So that is another 0.5. And then when there is no tension in the string, the particle travels 0.3 meters. So that means that the greatest height above the ground is 1.3 meters.